If I have a couple of points, P and Q, and I connect the dots, now I have a segment, PQ. It has a magnitude, it has a length that I could measure or calculate. If in addition I give it a direction, now I have a vector. This is vector PQ. I'm going to write it like this with a little arrow over top. A lot of the time I sort of write half an arrow like that. Either way, vector PQ. If I have coordinates for the point P, we'll call them P1 and P2, X and Y, and coordinates for point Q, guess what we're going to call those, then I can come up with the component form of the vector PQ by subtraction. I'm going to subtract the terminal point minus the initial point, the end minus the beginning, and I'm going to put that in, I like to call them pointy brackets. I have also heard them called chevrons. So I'm going to go the end minus the beginning. So the difference, essentially the difference of the x coordinates, the difference of the y coordinates. If I want to know the length of my vector or the magnitude of my vector, a lot of the time we see it with two lines, kind of like absolute value idea. But some books use one line. I'll try and remember to use two. This is the length, the distance from P to Q. Well, we have a formula for that. It's the distance formula. The square root of the difference of the x coordinates plus the squared plus the difference of the y coordinates. I said difference and I wrote a plus. Let's fix that. There we go. So the magnitude or the length of the vector looks like that. Let's do one with actual points, actual coordinates. Have coordinates for P, coordinates for Q. Just for fun, we might as well, I want to draw vector PQ. So I have point P, 3, -2, and point Q, -1, 3 is right there. Vector PQ goes specifically from P to Q. If I want it to go the other way, I have to call it vector QP. This one's going from P to Q. So there it is, vector PQ. Its component form I'm going to get by subtraction, the end minus the beginning. So -1 minus 3, comma, 3 minus -2. And we're going to actually do that. -4, +5. There's the component form of vector PQ. This is equivalent to vector PQ that we've drawn here starting at the origin. So if I put my initial point at 0, 0 and do this, I'm going to go -4 in the x direction and +5 in the y direction, like that. I'm going to get an equivalent vector with the same magnitude and the same direction. Let's find the magnitude of our vector. If I start from component form, -4, 5, I've already done the subtraction. So I can do this with the square root. Yes, I can put -1 minus 3 squared, or I can just put -4 squared because I already did the subtraction, plus 5 squared. So what do we got? 16 plus 25 is the square root of 41. That'll be our exact magnitude. If we want an approximation, that's somewhere between 6 and 7. So component form and magnitude of the vector PQ.